The second way that a law of conservation of mass question can manifest is in looking at amounts of products and reactants. We're not even talking about balancing an equation anymore. So let's use the old equation that we had, that we balanced, and let's look at a different form of law of conservation of mass type question. So another way of looking at whether or not the law of conservation of mass is actually being adhered to is by looking at the amounts of each of these molecules. So if I were to tell you that you had 35 grams of NaCO3, you had 24 grams of CaCO3, and you had 52 grams of NaCl. How do we make sure that the law of conservation of mass here is actually, maintained? If I were to ask you what amount of calcium chloride is required to ensure that the law of conservation of mass is maintained, what would you do? This is the unknown. You have no idea how much this is. So if you look at this, we remember that the law of conservation of mass implies that the amount of reactants must be equal to the amount of products. Now here we're not looking at the actual numbers of molecules. We're looking at an actual mass of, let's say, a powder or something. And we measure this using a triple beam balance or a balance of some sort. Okay, so the fact that you have 2 here and 2 here does not mean that you have 70 grams of this. It means that all of this equals 35 grams. You forget what the numbers out front or the little subscript numbers mean. If you see an equation like this, in a balanced equation, we're saying here that we've got 52 grams of NaCl. We don't care that there's 2 molecules of NaCl in that actual equation. We're saying that you got 52 grams of table salt there, NaCl. So in order to see how this can be maintained, you have to sum these two guys up. 24 plus 52 is going to be equal to 35 plus x. And this is a really simple mathematical equation if you want to isolate x. You sum these two up and that gives you 76 over here. So 35 grams plus x is equal to 76 grams. Well, x, if you isolate it, is 76 grams minus 35 grams. So what does x give you? 45. So x is equal to 41 grams. In order to maintain the law of conservation of mass, or matter, you've got to have 41 grams of calcium chloride in this equation. This is the other type of kind of problem that you could see. This is a far easier problem than, balancing an equation. Okay? But what they often will do to trick people is they will, they'll tell you that there's 2 molecules of this. And so what the mistake ends up being is people multiply this. They think that there has to only be 52 grams of NaCl. And if there's actually 2 in front of it to balance the equation, they think, oh, well, I must have to multiply that by 2. You do not. Okay? These amounts are looking at the balanced molecules. They don't care what big numbers, whole numbers are out front of the molecule or what little subscript numbers there are for each of the atoms within the molecule. It's looking at the actual molecule as a whole. It's telling you that you've got 35 grams of sodium carbonate. We've got sodium carbonate in the prep room. It's a nice little white powder. We put it on a scale and we mass out 35 grams. We don't care what the chemical formula is here. Okay? These are looking, this type of problem is looking at the actual amount of stuff that is that actual molecule. Doesn't care that there's two of them in a balanced equation. Okay?